So here, let us consider the first question. A rental car company claims the mean time to rent a car on their website is 60 seconds with a standard deviation of 30 seconds. Okay, this is the claim of the rental car company. Okay, let's read the complete question and then we will get the information. A random sample of 36 customers attempt to rent a car on the website. Then 36 customers, which is a sample, try to rent the car just to test whether what they are claiming is correct or not. The mean time to rent was 75 seconds. Now, okay, this is the information. Now, is this enough evidence to contradict the company's claim at 1% level of significance? Okay, so we need to see what are the information. So first of all, see, we have the numbers available here. Rental car company, so here they are talking about in general about the car company, which claims that mean time to rent a car is 60 seconds with a standard deviation of 30 seconds. So it is talking about the entire website. Okay, then a sample of 36 customers attempt to rent a car on company website. Now, since they continuing the sentence, now they are continuing the sentence, though say they are still talking about the sample. The mean time to rent was 75 seconds. And how do we know that it is a time for this one, this sample? Because mean time for the population is already occurred. Now, what is next? Is this enough evidence to contradict? We need the keyword which will help us to prepare the alternative hypothesis. Is this enough evidence to contradict the company's claim at 1% level of significance? So now let's get the information. What do we have? So see, so we already highlighted the information for this. Now let's work on it. So as you know that we need to get this information, population. From the population we are looking for mean and standard deviation, and we need to check what is available from the sample. Sample size, sample mean, or samples and sample standard deviation. Then depending upon which standard deviation is given, standard deviation sigma, that is from population, is given, then we will use z-test. Whereas if standard deviation for sample is given, we will use t-test. Okay, by using this testing formula. So let's do it one by one. So let's write it from the population, and these are the things from the sample. Or let's write the sample things down only and sample. So if we, now I will write the notations only, mu and sigma. From the sample we are looking for n, x bar and s. So we will see what are the quantities that are, which of the terms are given. So if we read the first line, a rental car company claims mean time to rent the car on their website is 60 seconds. 60 seconds. So this is the time that that's the website is taking. So they are talking about in general about the website. So this is population mean. Okay. So this will be 60 seconds. And the standard deviation is 30 seconds. So still it is talking in general about the website. So this is population standard deviation. Then we are looking from the, so from here it is clear that from population this standard deviation is given. It means it is going to be Z test. Okay, so let's see. Let's get the remaining information. So as it is going to be Z test, it means this should not be given. So let's see whether it is true or not. A random sample of 36 customers, means 36 customers attempt to rent a car. So N means the size of the sample. So here it is 36 customers. Okay, 36 customers attempt to rent a car on the website. Now the mean time to rent was 75 seconds. So now as we are continuing the sentence, it means now these 36 customers, the feedback given by these 36 customers is that it takes 75 seconds to on an average to rent a car. So this is the sample mean, 75 seconds. Now see, no more information is given related to the standard deviation. This is of the sample. So this is not available. It means yes, it is a case of Z test. Now let's see what else is given. Is this enough evidence to contradict? So we have the keyword contradict. Okay. Contradict the company's claim at 1% level of significance. So we denote the level of significance by alpha. So level of significance alpha as 1%, or we can write it as 0.01. Okay, so this is the information that is available to us from the test, from the question. Now we need to apply the testing process to get the solution. Now, so the very first step will be to frame the null hypothesis and the alternative hypothesis. Okay, so null hypothesis we denote by H naught, mu equal always, alternative hypothesis HA, mu. Now we need to check what will be the sign. It is less than, equal, not equal, or greater than equal. Okay, so now null hypothesis. So we are saying that in the null hypothesis we go with the claim. So we go with the claim of the company that it takes on an average 60 seconds to rent a car. So you can write that as a statement from the question itself, that it takes the mean time to rent a car or through a website, through a company website, is 60 seconds. Okay, this statement can be added here. Let me just write it. Mean time to rent a car through website is 60 seconds. Means we are accepting the claim of company. So in this case the null hypothesis become 60 seconds. Now we need to know what will be alternative hypothesis. So for alternative hypothesis, you remember I got you the word contradict, because what we need to check, all these data that is available to us, the mean, standard deviation, sample size and sample mean, is this evidence enough to contradict the company's claim? Now we just want to contradict, we want to check if it is contradicting, is it enough to contradict or not. So we have this word contradict. So we are not saying that it is higher or less, means it is going to take more time, more than 60 seconds to rent a car, or it is take less than 60 seconds to rent a car. But we just want to say that it contradicts. So when we have the word contradict, it will give you not equal to. So I hope you understand the meaning that we are using here, contradict. So this stands for not equal to. So this is the keyword. So this is important to identify how the sign of the alternative hypothesis. So in this case, you will write alternative hypothesis is not equal to 60 seconds. So what we got? Null hypothesis. So we will say that mean time to rent a car through website is different than, we can write it in the statement. What does it mean? That is mean time to rent a car through company's website is different. We use the different. We are not saying higher or less, different than 60 seconds. Okay. Now, what kind of test it is? When null hypothesis is equal and alternative hypothesis is not equal, we know that this is called a two-tailed, or we say two-sided test, right? So we need to identify this, all this information, because it is required to compare the values. Okay. Now, what is the next step? After getting this information, what we need to do is we need to perform the test value, calculate the test value. Now we know that it is a z-test, so we will be using this formula. So having this formula, begin then. So using the test statistics, we have z, this is step 2, test value, calculating the test value. So z is equal to x bar minus mu over sigma, and I will say multiply by root n. Instead of, I'm using the other version of the formula to avoid any kind of calculation mistake. I'm using this thing. Okay, now we have all these values. X bar is 75, mu is 60. So let us substitute it here. This is equal to x bar is 75 minus mu 60 divided by sigma, which is 30, times square root of n. N is 36. Let's do the calculation by calculator first. 15 multiply root of 36 is 6 over 30. Check what value you will get. So we get the value of z as 3. So z value comes out to be 3. This is by calculation. Okay. Now what we have to do is we need to identify that whether this value is correct or not. Means what do we mean by correct? Means with this z value, are we going to accept this hypothesis that yes, it takes 60 seconds to book to rent a car through a website, or we are going to say that no, it is not 60 seconds. To do that, what we need to do, we will compare this calculated value of Z with the already existing values. Okay, so for that we have to identify, after comparing that value from the means we have already calculated values in the form of table, and I'll show you how to get that values from the table. And then we identify the critical region. So we say that step 3 is to identify, to find the Z value from the table. We have a Z table, okay, which is having some standard values that we require for comparison and finding the critical region. Okay, so the table that I am going to show you now is a table which can be used for both t-test as well as for t and z-test. It is named as t-table, but you can see that it is also having the z values at the down. This row represent the z values. So t values I will be explaining you later. First I will explain you z values. So z values will be one of these numbers that you have to select. Now, to understand this table, how do you know that out of all these values, because z corresponding to z, this entire row, how do you know that this is your value? Which value you have to take? You have to take 0 or 0.674 or 0.842 or it is 3.291. How do you decide? So to decide that, there are some parameters, so which are given on the top of the table. So see, here it is given cumulative probability, which we are not considering. We will identify one of the value on the basis of the type of test. It is one-tailed test, means one-sided test, or two-sided test. Okay, and the second parameter that we need is to know the level of significance. See here, the level of significance, all these values are level of significance, but instead of percentage it is given in terms of decimal values, their decimal values. Like 1% means 0.01. Similarly 5% means 0.05. Okay, so all these things are given here. So let us see how it works for our question. So in our question, what do we have? We have level of significance 0.01 and the type of test is two-tailed, or we can say two-sided test. So we have these two information with us. Okay, so let's see what it gives you, Z value from the table. So remember, two-tailed test and level of significance is 0.01. So one-tailed, two-tailed. So it is two-tailed test. Okay, and from here we are looking for 1%. Don't get confused with 0.10 because this will be 10%. So we need 1%. So it means this thing. So this row and this column. So in this column, if we go downward, the value corresponding going down to this one is here. So we selected, see, once again we selected two-tailed test, level of significance 0.01 because it is 1%. So our value comes out to be this number. Let me just increase the size. So Z value, as we have to select one of the values, so how do we select it? On the basis of test. So it comes out to be 2.576. So we write Z value from table is 2.576. Okay, now in place of 1%, if it is given as level of significance as 5%, then you will be looking the value along this row and it would be 1.96. Okay, So this is how you calculate the value from the table. For t-test, I will be explaining you later while solving the questions of t-test. Okay, now this is the z value from the table. Then after getting the z value by z value by table, we will identify the critical region. Yeah. Now to identify the critical region, what we have to do? We will make use of this tabulated value. There are many ways to identify the critical region, but I'll pick the one which I found easy. So let's draw a number line. Okay, then this is the value that we got, okay, from the table. We have to make use of tabulated value. So let me erase and draw a neat line. Okay, so this point, suppose if this is your point 0, let's point this point as on the number line 2.576 on the positive and the negative. Okay, then the region towards the left of negative of 2.576 and towards the right side of positive 2.576 is the critical region. This is the critical region. This shaded region up to infinity. This critical region. So what do we mean by critical region? Critical region, in other words, we say that region of rejection. Region of rejection. So it means if the calculated value lies in that region, we will reject the null hypothesis. Okay, otherwise we will accept the null hypothesis. So this is region of rejection. Now let's see where our point lies. We have the value 3. Okay, the value of z is 3. Where it will lie? It will be definitely greater than 2.576. So it will be somewhere here. Say z is equal to 3. This is from the table. So what is happening? Our value lies in the critical region, isn't it? Our value is lying in the critical region. The value is here, and if we plot the point z is equal to 3, it will be somewhere here. So this value lies in the critical region. Okay, now once it lie in the critical region, it means do not accept it. Do not accept the null hypothesis and accept the alternative hypothesis. So what you have to write? This will come as step 4, sorry, where you are making the decision. So how you will write it? As the calculated z value lies in the critical region, we do not accept the null hypothesis. So what was our null hypothesis? Null hypothesis was the claim that was given by company that it takes 60 seconds to rent a car by using the website, which is not true. So it means the mean time, on an average, it takes more than 60 seconds to rent a car through their website. So we can say that hence it takes or means we cannot say that it is more or less. It could be less because we are saying that it is not 60 seconds. Hence, the mean time to rent a car through company's website, sorry for spelling mistake, for company's website is different than 60 seconds. So it's better to use it is different than 60 seconds instead of saying that it is more or less, because we are going with the alternative hypothesis that this is not true. Null hypothesis is not true, that it is not taking 60 seconds to rent a car, but it could be higher or less than 60 seconds. So we just say that it is different. That's why we are using the signature as a symbol as not equal to. So this is the solution of this problem. So you have to include all these 4 steps while explaining the question. Clear?